Hi guys, my name is Terry. In this video, I'm going to go through with you the Form 5 Additional Mathematics textbook question for Chapter 1 Circular Measures Summative Exercise. If you enjoyed this video, kindly like, subscribe, or leave us a comment. So, let's get straight to the first question. Diagram shows sector QL from a circle with center O, radius 10, area of sector is 60 square cm. So calculate value of theta. Now, so from the beginning of chapter, we learned before that the area of a sector is given by half r squared theta. Okay, so this area is 60, so we know that the radius is 10, so I'm going to write half 10 square theta equals to 60. So use your calculator. 10 square is 100 divided by 250. You can just divide directly. So theta is just 60 over 50, which is 1.2 radian. Okay. The next thing is you want to find the perimeter of the sector. Now perimeter is basically the sum of the length of all sides. So this is 10 cm. The length of arc here we can calculate by using S equals to r theta. Now you can do one by one, or you can do one shot. Okay, if I were to show you one by one, the length of arc KL is just the radius 10 times theta 1.2. This is 12. So your perimeter is basically 12 plus 10 plus 10. That will give us 32 cm. Right? A fairly simple question. Moving on to question number 2. Diagram on the right shows sector AOB from a circle with center O, given that AD, DO, OC, and CB are all 3 cm, meaning this is 3 here, this is also 3, 3, 3, all 3 cm. So you're supposed to find perimeter of the shaded region. Now the shaded region here, we can basically add up the length of this 3 cm, 3 cm, chord DC, and also arc AB. Now the thing is about chord, right? I wonder whether you guys have seen this formula before. I probably have discussed this before in a previous video. The length of chord can be calculated by using 2r sine theta 2. Personally, I like to use this formula because it's faster. You don't have to like split the triangle to 2 and then use sine to calculate the length of chord. Okay, so if we were to use this formula, the length of DC is just 2 multiplied with the radius, which is 3 sine your theta is 2 radian, half of it is going to be 1 radian. Now notice I put a superscript r to indicate that it's in radian. Now when you use your calculator, remember to use your calculator in radian mode. Key in your calculator, you should get 5.049 cm. Okay, if you cannot remember this formula, what we can do is we can split this into 2. Okay, let me redraw this so my triangle looks a little bit ugly. Well, it looks like this. When you split into 2, and this is DOC. I'm going to call this T for Terry. This is going to be 1 radian. Why 1 radian? Because we halve it. The 2, you bisect in the middle. Yeah, it becomes 1 radian. And this is now 3 cm. So if you were to use sine theta, in this case your theta is 1 radian, you will get dt over 2 and over 3, sorry, 3, your radius is 3, multiply over dt is now 3 sine 1 radian, but we're not finding dt, we're finding dc. Dc is twice of this. Now you notice it's actually the same as using this formula directly, right? So if you can remember, the formula is faster, 2r sine theta over 2. Okay, how about the perimeter? Well, you still need to find the length of arc AB, and arc AB will be r, which is now 3 plus 3, 6 cm, because the whole thing is longer. AO is 6 cm, times theta 2 radian, that will give us 12. So your perimeter will be, add them up, AD is 3, BC is 5.049, CB is 3, and AB is 12. So when you add up, your answer is 23.049. Now actually you don't have to use such an accurate answer. This is 5SF, but I think the textbook uses this, so we'll just stick to 5SF. Okay, so next one, area of the shaded region. Now you can actually use the formula for area of uh, triangle half AB sine C. Remember in circular measure, in solution triangle form 4. Yeah. So we take the big sector minus the small triangle. Your big sector has radius of 6, angle is 2 radian, right? Half r squared theta minus half AB. AB will be 2, will be 3 times 3. Okay, we can write 3 squared sine 2 radian. So this will be 31.0908. Yeah, 31.908. Okay, fairly simple as well. All right, that's question number 2. Let's move on to question number 3. Diagram on the right shows sector POQ and ROS with the same center. OP is 4 cm, ratio OPOR is 2 to 3. Now it's 2 to 3, meaning if my OP is 2, we can write, I'll just write here, if your OR is 2 over 3, if your OP is 4 cm, OR should be how many cm? You just multiply 2 times 2 is 4, 3 times 2, OR should be 6 cm. If your OR is 6, if the holding is 6, meaning PR should be 2 cm. Okay, number 1, you're finding the value of theta in radian. The area shaded region is 10.8. So this is what we call area of concentric sector. So there is actually a formula for this, but if you don't want to remember, it's okay. The formula goes like this. Half the big sector is r squared theta, small sector half r squared theta, small r, you take up half theta, r squared minus r squared. Yeah, if you want you can use it, if you don't want it's okay. So you can do separately, it's the same actually. So let me just use this for now. My theta is an unknown, my big radius is 6 cm, 6 square, my small radius is 4 cm, 4 square, and this will give us 10.8. So 6 square is 36, 36 minus 16, that will be 20, half of 20 is 10, so we can just write this as 10 theta. Yeah, you can use a calculator if you can't calculate mentally. Theta will be 10.8 divided by 1.0, divided by 10 is 1.08. You don't have to write a 0 at the back. 1.8. 1.08 will do, don't need to put an extra 0 at the back. Okay, so that is your theta. How do you find perimeter shaded region? Okay, this is also not difficult. Basically, we add the length of this arc, PQ, plus arc, RS, plus the length of two sides. Okay, so from now on, I'm not going to show you step by step because I think you can do one shot. It's not too difficult. Okay, if you want, I can just show you length of arc PQ, length of arc RS, plus the other two will be 2 and 2. If you want, you can write PR and QS. Okay, your radius is now 6, your theta is 1.08. The other one, the RS radius is, I think RS is bigger, PQ is smaller, PQ is 4. RS is 6, so I'm going to write 4 here. This is for your reference, but you don't really need to write the first line, you can just write this, the second line straight away. 4, 1.08, plus 6, 1.08, plus 2, plus 2. Use your calculator, calculate one shot, 14.8 cm. Now, I'm not a big fan of doing one by one, because when you do one by one, sometimes you have a lot of decimal point, right? And then you tend to round off, then you add it together, so answer is not the same. So it's always better to do it one shot. Use your calculator so that you don't have to deal with the accuracy, rounding off, and so on. Okay, so let's move on to question number 4. Now, in this sector question, sector MON is a circle angle theta, radius is r, given that perimeter sector is 18 and area is 8 square cm. So form a pair of simultaneous equations, solve them simultaneously. Okay, this is more like simultaneous equation rather than circular measure, but we use the concept of circular measure. So we already know that perimeter is r plus r plus r theta. So we can just use that to form the first equation. I'm going to write r plus r, maybe we write 2r plus r theta equals to 18. Alright, so they say form a pair of simultaneous equation. Actually, this is already the answer. We can actually stop here. Yeah, because your equation will have theta and r. So I'll leave this out first, equation 1. The second equation is your area. Area is also simple. Your area here is 8, so we use half r squared theta equals to 8. Okay, now the next one, we want to solve this simultaneous equation. So I think ideally we need to make one of them as a subject, because this is a non-linear. Non-linear, we would usually solve it using substitution rather than elimination. So I'm going to start from equation 1. I think it's better to make theta as a subject, because if I make r as a subject, notice I have to square it. So the working might be a little bit longer. So I make theta as a subject from equation 1. R theta equals to 18 minus 2r. Theta is 18 minus 2r divided by r. So I call this equation number 3. And as we sub equation 3 inside equation 2, your theta is now 18 minus 2r over r, and this is 8. Okay, now notice we can cancel the r and r squared. You're left with half and r. Now let's multiply inside 1 by 1. So this will be 9r minus r squared equals to 8. So what we have here is a quadratic equation. Then we can rearrange it. So I'm just transferring everything to the right. I'm bringing everything to the right. Left is 0. So I'm just going to instead of writing 0 on the left, I write 0 on the right. Double bracket, factorize this. Yeah, this is 8 and 1, minus and minus. Your r is either 1 or 8. You have two possible values. Okay, now we're going to take this value and sub inside of theta. So when you sub inside equation 3, when your r is 1, your theta is now 18 minus 2 times 1 over 1. So this is 16. Can your theta be 16 radian? That is quite impossible. Right? You know, one whole turn, or should I say one straight line like this, right? The angle will be, your theta is 3.141 pi, correct? So 16, it is a few round, right? So now one whole turn is 2 pi radian. 2 pi radian is approximately 6.28. So that's not possible, right? So or to reject this answer, we know this is not a possible answer. You can either say that, you can see from the diagram, theta is an acute. Theta is acute. Yeah, acute means it must be less than pi over 2. Pi over 2 is approximately 1.571, right? So that's why we have to say this is an invalid answer, right? Yeah, r we just say is invalid, invalid solution, or you can say reject. But I don't like to say reject. It sounds very mean. Reject. You're rejected. Okay, so let's take r equals to 8. Theta equals to 18 minus 2 times 8 divided by 8. Okay, 18 minus 16 is 2. 2 divided by 8, 1 over 4 radian. So your answer is r equals to 8 and theta equals to 1 over 4 radian. Okay. Moving on to question number 5. Diagram on the right shows a square ABCD with a side of 4 cm. Alright. PQ is an arc of a circle with center C whose radius is 5. So calculate angle PCQ in degrees. Okay, so to find angle PCQ, number one, if I know this is a square, this is 5. Can you see the radius is 5? So we can find, well, this angle first. Now you want to call this PCQ is the angle between, and maybe you can call that theta. I'm going to call this alpha, right? So now you have a few options, and some people will find the angle in radians straight away, then convert to radian. Some people find the angle in degree, then you convert back to radian. So, and I see, I worked it out earlier, and I noticed that textbook actually find the angle in radian first, then you convert to degree, right? So there is a slight difference in the answer actually, right? If you were to use degree to radian, radian degree. Okay, so now let's just use radian. Okay, so I'm going to use cos alpha equals 4 over 5, right? Your opposite is here, your adjacent is 4, hypotenuse is 5. Yeah, in fact we can say that opposite is 5. It's 3. Yeah? We know that it's 3, 4, 5, right? So this is your hypotenuse. Sorry, hypotenuse here. We know from that ratio 3, 4, 5. Yeah, opposite is supposed to be 3. Yeah. Okay, but never mind. I know 4, I know 5. I use cos. So use your calculator, cos inverse it. Now if you use your calculator in radian, then your answer is 0.6435. Yeah, if you use your calculator in degree, you will get 36.87. Okay, yeah, depending whether you're using degree radian. Now if you use radian to find this angle theta, PCQ, I call it theta, right? I need to use 90 minus that 2 alpha, because this is what identical. Yeah, angle QCD and PCB, they are actually the same. They are both alpha. So we need to use 90 in radian is pi over 2 minus 2 times of 0.6435 to get your theta. Now my theta from here is 0.284. Okay, this is in radian. Then when you convert to degree, it will be 0.284 times 180 divided by pi. You will get 16.26, but the textbook uses answer in degree and minute, so it's 16 degree 16 minute, right? Or if you actually, if it's not stated, you can use 2 decimal point, right? Unless the question say leave your answer in degrees and minute. If they don't mention minute, you can actually leave it in degree, correct to 2 decimal places. All right, next one. How do you find perimeter of the shaded region? Okay, perimeter of shaded region actually consists of this arc. Let me highlight for you this arc PQ here, and the length of this two side. Yeah. Okay, the length of arc is fairly simple. We can just use S equals r theta. And the other two side also we can actually calculate directly. It's 1 each. How do I know it's 1? 4 minus 3. The square has a length outside of 4. So you minus 3 here, you're left with 1. So your perimeter is basically, can I just say 1 plus 1 plus r, radius is 5, your theta is 0.284. Okay, and you will get 3.42. Okay, now I want to stress on this because actually if you use ideally we should use all our answer correct to 4 significant figure, right? So if you use 4 significant figure, this should be 2838. Yeah, 2838. But like I said, the textbook uses most of the answer in decimal correct to 3 decimal point. Yeah, mostly the theta all 3 decimal point, so that's why you will get this. But if you use 0.2838, which is what I would recommend, you will get 3.419, which is actually a better answer. Okay, just so you know, this is your textbook answer because they use theta as 0.284. If you use more decimal point 2838, then your answer is 3.419. Yeah, which in my opinion is a better answer. Okay, now let's look at C, area of shaded region. Now your shaded region, we can just take the big square minus the 2 triangle and minus the sector. Okay, your big square is like this. You minus these 2 triangle, first triangle, second triangle, they are identical, right? They're identical. Okay, and then you minus this sector in between. So my big square is 4 square. 4 times 4 is 4 square. Then you minus area triangle, 2 of them, half times base times height. And area sector is half r square theta. Again, there is a difference if you were to use 0.284 versus 0.2838. If you use 284, your answer will be 0.45. Alright, but if you use 0.2838, your answer will be 0.4525. Okay, All right, next question. Now, diagram on the right shows a quadrant with a center O and radius of 10 cm. So Q is the arc of a quadrant such that the length of arc length PQQR is in the ratio of 2 to 3. So given POQ is theta, find the theta. Okay, this is very interesting because we tend to, uh, we need to compare the length and then therefore find angle theta. For me, I would use a proportion method like this. We know the length of arc PQ, but instead of using PQQR, right? Let's use PQPR. Why? Because we know PR, the angle subtended by arc PR, the quadrant, is actually 90. 90, there is a value in radian, it's pi over 2, right? We know this ratio is 2 is to 5 because this is 2 to 3. If you add up the whole thing, the ratio is 5, right? Now, length of arc is S equals R theta for PQ, right? For PR, is R times pi over 2 because it's 90 degrees, so it's 205. Now, let's cancel them and bring it over. Cancel this R and R. Theta is now 2 over 5 times pi over 2. My theta is pi over 5 radian. Okay, if you were to change to decimal, I think the textbook give answer in decimal, right? Your answer should be 0.6284. Okay, all right, this one I use for SF. Okay, that is the value of theta. Next, calculate area of shaded region. Okay, to find area of shaded region, there are two parts to it. One is a triangle, and one is the sector of circle. Okay, now I like to use half r squared theta plus half AB sin C because I find AB sin C is much easier. Your R is 10, you square it, theta is 0.6284, right? Okay, maybe for the area of what do you call that triangle here, let me just find out what is this. I call it alpha. We know that alpha will be, let me work it out here, pi over 2 minus theta. Remember, every time we use this pi, please use 3.142. Yeah, when you type in the calculator, yeah, this will be 0.6284. When you minus 90 minus, this will give us 0.9426. So I like to use area of sector plus area of triangle, half AB sin C. Your A is 10, your B is also 10. So we take 10 squared sine 0.9426. But please use your calculator in radian mode. See that the superscript R is to indicate that it's in radian. Now if you type in your calculator, you should get 71.87. Now if you don't want to use this, you can, some students they prefer to split this into, which I think is a bit slower. You divide evenly the center. Now we know if your alpha is 0.9426, so you take 9426 divided by 2. This angle is 0.4713. Then this is your height, right? You know your radius is what do you call that? Your radius is 10. So we use cos theta equals cos 0.4713 in radian, h over 10. So calculator in radian mode, cos 0.4713, you times 10, you find your height first, which is 8.909110, and then you take your area, just want to put an or here, half r squared theta 6284, you plus half times base times height. Well, your base, oh, see, you have to find your height. Yeah, it's very long. Your base is this is your height. You don't know what's your base. Your base, you can use sine or you can use Pythagoras theorem. Yeah, okay. If I use Pythagoras, let me call this x. So x is now 10 squared minus 8.910 square root. Yeah, 10 square minus 8.91 square root. So this is 4.540. So base is 4.54, but you have to times 2 because this is 2x, so I times 2 here. Your height is 8.910. Oh, this is very long in my opinion, so that's why I fancy half AB sine C, because yeah, it's short and precise, right? Okay, so you will get the same answer, 71.87, right? Okay, understand that the difference between these two methods, half AB sine C is the winner, short and simple. All right, let's look at question number 7. Diagram on the right. You have a semicircle PQRS with center O, radius is R, arc length PQ, QR, RS are actually the same. So if you have 3 equal arc length, meaning if these 3 are equal length, so number 1, we can take this and join together. We know this 3 must be the same angle 60, right? So 60 degree, we know it's an equilateral triangle, so all 3 are equilateral, right? And we're supposed to calculate area of shaded region. Now if it's equilateral, because these are the radius, this is a radius, this is a radius, so all of them are 60, so this is 60 as well, this is 60 as well. Can you see? So to find the area triangle has nothing to do with circular measure. It's more like solution of triangle, because you don't need to find you don't need to use s equals r theta, you don't need to use half r squared theta, right? Okay, so we just have to use half AB sine C to find area of triangle. Now this triangle looks like this. Let me draw. Oops, doesn't look very nice. Like this. The radius are the same, r and r, and we know this is 120. So your area is just half AB or square it sine 120. Okay, you're supposed to leave your answer in terms of r. Okay, in Form 3 trigonometry, you learned before special angle sine 60. Sine 60 equals to sec 302. Okay, but you're going to learn this again in Form 5, chapter 6, yeah, about sine, even your Form 5 mod maths, trigonometry as well, right? So you can use your answer in third form, but I think the text will just type in the answer, the calculator, and give answer in decimal. But actually sine 120, we can actually get this answer if you are using the silver calculator or the black and white calculator. They will give us sec 3/2, which is going to give us sec 3/4 r square. But if you don't use this calculator, use the gray calculator, you will get your answer in decimal, and I think the text will give answer in decimal, 0.433 r squared. So it's very simple. But I know some people say, oh, I don't know how to use half AB sine C. Okay, because you never learn solution triangle, right? Well, you can half it and say, if this is r, this is 60. This is q, this is p. Let me call this t for Terry. So I'll find pt first. If you want to do it one by one, it's step by step. All right. We can say sine 60 is pt over r. Pt is sine 60 is sec 3/2. Type your calculator, or you can leave it in decimal. Sec 3/2r. And then you can use Pythagoras, or you can use cos. Pythagoras Pythagoras means I use sec 3/2r here. Let's say I use qt. Qt will be r square minus sec 3/2r square. This is qt square. So r square minus 3/4r square is half r square. When you 1/4r square, but when you square root, you should get half r. So your area, we can just say half times base times height. Then you times 2 because you have 2 of them. You still get the same answer, where you get sec 3/2, sec 3/4r square. Okay, let's move this up a little bit. Or you can write 0.433 r squared. So by now I hope you know that half AB sine C is so much easier, right? Okay, let's look at question number 8. Now, in this case, we have sector VOW. From a circle with center O, the arc VW subtend angle 2 radian at the center. The sector is folded to make a cone such that arc length VW is the circumference of the cone. So we draw like this. Okay, so this VW is now the circumference, right? So which is here, right? We are supposed to find what? We're supposed to find the height of the cone, the height of the cone H here. All right. Now, one thing you know to know the difference between slant height and vertical height. Slant height, when you fold this, right, this slant height is actually 64, which is the same as the radius of your sector. But first, we need to find the radius of your cone. Now, your circumference here, circumference of cone must equals length of arc of your sector. Right? Circumference, let's call the radius here r. Circumference is 2 pi r. The length of this arc here will be 64. S equals r theta. Theta is 2 radian. So just use your calculator. 64 divide by pi. Pi will be 3.142. Your answer is 20.369. Just use more decimal point to be more accurate. Yeah, this is 5 SF actually. Yeah, actually, 4 SF is good enough, but let's just use 5. Okay. Now, I want to find height. So the height here, can you see, is actually a right angle triangle over here, right? So I know the radius already. I'll just use Pythagoras. 64 square minus 20.369 square, put a square root over. My height is 60.672, and I think the textbook rounded off, yeah, to 60.67. See, that's the thing. For me, I would use 4 SF every step of the way, but you can see sometimes the answer in textbook they give 3 decimal, 5 SF, sometimes they give 4 SF, sometimes they give 6 SF. Yeah, it's a little bit inconsistent, right? Okay, now let's look at question number 9. Diagram on the right show semicircle AOB with O as the center. The triangle ABP is right angle at P. Given AB equals to 16, ABP is pi over 6 radian. Find the length of AB. Okay, now you can see from here, if this angle is pi of 6, pi of 6 means what? 100. If you're not familiar, pi is 100 here. You divide by 6, what do you get? 30. Is 30 degree. Yeah, you can think that way. Think 30. This is already 90 or pi over 2. So to find this angle, okay, angle BAB, it would be 180, which is pi, minus 90, pi over 2, minus pi over 6, which is pi over 3. Now, pi over 3 is actually 60. Yeah, I know some students, they find radian a bit confusing. It's actually the same thing, just that you need to get used to it. Pi over 3 is radian. It's 60, sorry. Now, in radian, I just have to join these together to be able to see that, oops, a little bit ugly. Join these together to be able to see that this two are equal, and this is also radius. So that means this AOP is actually an equilateral triangle, right? So now I know some people say, hey, you don't need to do that because we can see that this is angle subtended at the center. Remember this? This angle subtended circumference. Can you see that? Yeah, you can do that as well. Yeah, but I will still need that 60 later on. So remember, angle subtended at the center and circumference. This is double of this. Yeah, sorry, a bit ugly. I'm using the highlighter. Okay, so you can do that as well. And straight away say this is pi over 3. This angle is double this. But if I know this is pi over 3, everything else is pi over 3. And this triangle AOP is equilateral. So length of arc AP, we use S equals R theta. Okay, do you know what's your radius? AB is 16, so this should be 8 and 8. Diameter is 16, radius is 8, right? Okay, sorry, you're not finding length of arc AP. Oh, you're not finding length of arc AP. You're finding length of chord AB, sorry, length of chord AB, yeah, but they should just say length of chord, right, not length of arc. Okay. Well, then this will be just 8 cm because it's equilateral. Must I mention here? Must I mention here that OA equals OB equals AB? So triangle AOB is equilateral. If it's equilateral, so AB must be 8. They're all equal length, right? Okay lah, no need to mention equilateral. I already say that equal length already. Okay, now next, I know to find area of triangle ABP, ABP, we just use half times base times height. Now the problem is I do not know what is the length of PB, right? When you use half times base times height, you have to use make sure that the base and height are perpendicular to each other. So too many lines here, I'm going to rub this off. Too many lines here. So we know this is 8. We know this is 16. So PB is just 16 squared minus 8 squared square root, which is square root 192, right? So your area triangle would just be half times base times height. Your base will be 8, your height square root 192. My answer is 55.43. Okay, I think textbook answer is 55.44. A slight difference. It could be possibly because they square root 192 and leave it in decimal. If you take square root 192 and leave it in decimal, or you round it off to 13.86, okay, let me say this. If you round off to 13.86, right? 13.86, then you times half times base, then you will get 55.44. Yeah, that is if you use you round off. So that's why I'm actually not a big fan of rounding off. I like to do it one shot, right? Because I feel square root 192 is better. You don't have to write so many steps. You don't have to round it off, and then you type in the calculator. It is the most accurate answer. Okay. All right. That is your area of triangle. Now you can actually also use half AB sin C. Half AB sin C is also quite fast. Yeah, it's actually faster, right? Okay. Now, how about area of shaded region? Okay, shaded region, basically we take area of this, we can say the area of this sector here, you plus this triangle, right? And then you minus this. Is it too difficult, or should I just use, okay, I can show you this way, right? Then you minus this. This is one way of thinking, because we want to use the result from the earlier part. Or you can just use area of segment, right? Okay, sorry, you're finding area of shaded region. Don't you do so long? Sorry, I'm looking at the wrong thing. Sorry, area of shaded region is a segment. Now this segment is actually this part only. So I like to use half r square theta minus sin theta. I think if you watch my previous video, I've already shown you this. The formula for area segment is given by half r square theta minus sin theta. It's basically derived from here, half r square theta, area of sector, minus area of triangle. Then you can put it together as half r square theta minus sin theta. This is actually a faster way of counting, right? Ignore the first line. You can just straight away use half r square theta minus sin theta. My radius is 8. Your theta, okay, theta, if you want the most accurate answer, of course you can use pi over 3, type in your calculator directly. But I think again, the textbook, most of the time, they like to round off to 3 decimal point. You will get 1.047, right? And then you can do this 1.047. But to enhance your accuracy, then I suggest you use sin 60. But your calculator must be in degree mode, because this is 60 degree. This is the most accurate way of doing. Yep. more, should I say the more accurate way, not the most accurate way, right? You just type in a calculator, change your calculator to degree mode, half, your radius is 8 squared, theta is 1.047 minus sine 1.047, or you can use sine 60 here in degree. I think you will get 5.791, okay, which is the same answer as your textbook. Okay, now you can also use area of triangle. Now some people, they go and split this into two, like what I've shown you before, right? This one's 8, this one is 8, they split into two, we know this is 8, they go and find this height here, right? So they use Pythagoras, they say, okay, this is half of 8 is 4, right? So I just drop off the 8. So we find the height of your triangle, which is 8 square minus 4 square square root. This will give us square root 48. Now, then you use area as half r square theta minus half times base. Your base is now 8, the whole thing. This one is your base, 8. And your height, square root 48. I think you get the same answer, 5.791. Okay? Right? Alright, moving on to question number 10. So in this question, diagram shows AOB is semicircle. This one is combined with coordinate geometry. Very interesting. It's actually a very old SPM question, 1990 something, right? I know you're not even born yet, right? Okay, so the first part, we're finding area of triangle ABC. So we don't use half AB sin C here. To find area of triangle, we call it the arrays method, or some people call it a shoestring method. The half x1, y1, x2, y2, x3, y3, repeat point number 1. Remember the coordinate geometry form 4. Now we start from here. X over 6 plus y over 8 equals 1. That means your x-intercept A is 6. Your y-intercept B is now 8. Okay, so your coordinate point A is now 0, 8. Remember, this is y-intercept. You don't look at A and A. You look at your B. This one is 6, 0. Your B is 6, 0. Okay. Now, to find the area of triangle, I'll just use half. Let's say I use A, B, C. The order I start off with 0, 8, 6, 0, 7, 7. Repeat point number 1. So let's multiply downwards. This is 0. This is 42. This is 56. Then you minus this way up. 48. This is 0. This is 0. My answer is 25. Yeah, square unit. That's part E. Okay, then you are finding angle ACD in degrees. ACD. Okay, to find angle ACD, we need to use trigonometry, SOHCAHTOA, right? But before we do SOHCAHTOA, we need to know what is the length of AC, or even length of BC. They are actually equal length. So let's say I find AC by using formula for distance, right? Formula for distance, x2 minus x1 squared, y2 minus y1 squared is 49 plus 1, which is 50. Or you can write 5 sub 2. I'll just write sub 50. Okay, how about the length of AB? The length of AB will be very simple. This is 6. This is 8. No need to use the formula. Yeah, just say 8 squared, 6 squared, or 6 squared, 8 squared squared. We know is 10. Right. So if I know this length already, right, I can just redraw for you here. These two are equal length. So this is 10. Half of it, 90 degree. You're finding ACB, angle ACB. So ACB in degrees, right? So we know this is square root 50. This is 10, half of it is 5. So let's call ACB is theta, half of it is theta over 2. So I will use sine theta over 2 is 5 over square root 50. You have to use your calculator. This will be, let me just So you write theta is 2 times of sine inverse 5 over sec 50. Now use your calculator in degree mode. You get 45 here. 2 times 45. Answer is 90. So this angle is 90. Alright. Move up, yeah. Now next, I want to find area shaded region. Okay, now area shaded region, again, I think we can use area of semicircle. I hope you can see this is a semicircle. Then you plus this triangle, then you minus this sector. Now you can also use area of segment, guys. You can even use area segment. We can say semicircle, semicircle minus your segment. Yeah, I've already taught you guys formula for area segment. However, because this is a 90 degree, so I think it's quite easy to use half times base times height. So this time I'm not going to use formula for area segment. I'm just going to use half times base times height to find area of triangle, right? So your semicircle plus your triangle. Okay, can you picture this? Semicircle plus triangle, then you minus this part off to get the shaded region. Okay, so your semicircle, we already know that the diameter of AB, the whole diameter is 10 from here. So AD is 10, so AD should be 5. Yeah, we already calculated here, 5 here. So the formula will be half r square theta. Your r is 5, square theta is pi. Why pi? Because 180 is 5 radian in radian. Then you plus the area of triangle, which I already found earlier. Here, 25, correct? Or you can use half times base times height again, not necessary. Minus area of sector, half your radius is sub 50, square 50, and your theta is 90. 90 in radian is what? Pi over 2. Now, interestingly, this is 25 over 2 pi plus 25. Square root 50, sorry, you have to square it up, is 50. 50 divided by 4 is also 25 over 2 pi. Then you minus it off. Well, your answer is the same as the area of triangle, 25 pi. Okay. Moving on to question 11. Okay. Now, diagram shows semicircle A, B, C, D. This is another question that related to coordinate geometry, and again, it's a past year question, old SPM past year question, 1990 something. All right, the center is F, B, G, D, F is a rhombus. If this is a rhombus, we know all this length must be equal. Okay, so the coordinates are all given, so you're supposed to find the value of theta. So I think the first thing I would do to find theta, we need a right angle triangle. So I'm going to take this rhombus, I'm going to split into two like this. Just draw bigger for you to see. All right, so this is F 5 6, this is G 5 8, and this will be theta over 2. The whole thing is theta, and we can split this further because these two are equal length. Yeah, and these two are equal length as well. So we can, yeah, because it's a rhombus, GD and FD must be the same. We can split in the middle, right? And in fact GF we can split in the middle as well. Okay, sorry, my line not very straight. Yeah, I can split this in the middle. Okay, next we can use SOHCAHTOA. In this case, I'm going to use cos. I know the length of GF. If this is 8, can you see 8? This is 6. That means this is 2 units above. G is 2 units above. So this length is 2. Half of it is 1. Right? Now at the same time, you can see the length of FE is, look at the x coordinate, 9 minus 5. 9 minus 5, they're on the same line, right? This is 6 and 6. They are horizontal. 9 minus 5 is 4. That means the length from here to here is 4. Can you see that? Yeah, the length from here to here. Sorry, wrong side. The radius is 4. Wrong side. Undo. Okay, the radius is 4. This is 4. This is 4. Can you see? 4. This is your D. So I have to use what? I have to use cos. Cos theta over 2 is 1 over 4. Theta is 2 times of cos inverse of 1 over 4. in radian, calculator in radian mode, you should get 2.636 radian. This is part A. Alright, part B, area of sector BFD. Okay, to calculate area of sector, we just use half r squared theta. We already know the radius is 4. So your area of sector is half r squared, theta is 2.636. I got 21.088, or you can round it off to 21.09. Okay, a square unit 21.09 would do lah. No need to use so many decimal places. I think the textbook also gives this answer. Okay, C, area of shaded region. Okay, to find area of shaded region, we just need to take area of sector minus the area of the rhombus. Okay, but for rhombus, right, we can split this. Okay, I need to find the area. We split like this into 4 smaller triangles. Okay, right. We know that if this is 1 and 4, you can see. You want I can redraw for you. Too many lines sometimes a bit hard to see. This is 1 is 4, right? We can find this height. Yeah, which is what, 4 squared minus 1 square square root, which gives us 15. So my area of sector, if you minus this 1 triangle, 2 triangle, 3 triangle, 4 triangle, you will be able to get this shaded region. Okay, now your area sector, we know, is 21.09, or you can write 21.088. Now area triangle, we can use half times base times height. Your base is 1, your height is square root 15. Sorry, I forgot to put a 15 there, square root here. And then you times 4. Why? There are 4 triangles. Yeah, they are identical. So then you will get 13.34 square unit. Alright, that is number 11. Moving on to number 12. So here we have a diagram that shows a circle JKLM. Down it. Alright, my key cannot see. Alright, here. We are supposed to first find the radius of sector of circle JKLM in cm. Okay, I think the radius we need to use either we use chord, like I said earlier in the earlier question, we talk about the length of chord being 2r sine theta of 2. Yeah, this jm is my chord. My radius is 7. My theta is 1 radian, so it's 1 over 2. You can just put 0.5 radian. You will get 6.712. But if you don't want to do this, you can split in the middle and count 1 by 1. Yeah. I think I don't show you that, right? Yeah. You can split in the middle. Yeah, this is 0.5 radian. You can say sine 0.5 radian. Let's call this t, jt over 7. Jt is 7 sine 0.5 radian. Jm will be 2 times 7 sine 0.5 radian. Now we're getting the same thing. And this is the length of jm, which represent the radius of your circle. Okay. B. Oh, by the way, sorry, just to confirm, the textbook uses, I think the textbook answer is 0.1 difference, 0.01 difference. Okay, just want to tell you that the textbook's answer is 6.711 cm. I guess it because they use a longer method, maybe they convert to degree. Yeah, so that's why the answer might be a little bit different, right, compared to if you were to use this formula for chord. Yeah. Okay, so next I want to find the perimeter of the shaded region. Your shaded region consists of 3 arcs. The first arc is JKL, second one is JM, third one is ML. So JKL, they gave us this angle already 3.8, but actually this angle, if you calculate 1 by 1, it's not really accurate. Yeah, it's not really accurate, but it's okay. We'll just take the answer. Your radius is 6.712, you times 3.8, you plus, for the smaller arc, right, you can see a smaller arc JM here. Your radius is 7, your theta is 1, you just times 2 because you have two of them. You use your calculator, you will get 39.51 cm. Okay, again, because the textbook uses 6.711 for the radius, your answer will be 39.54. So I put an OR here, so for your reference, one is using 6.712, another one 6.711. Okay, that is part B. Let's look at part C. You're finding area of sector JAM. Okay, JAM, too many lines here, so I'm going to run this off. JAM is just this, okay, this sector. So I'm going to just take, okay, sorry, a bit ugly, never mind. You can see I know which one. I'm going to use area as half r squared theta. Your theta is 1 radian, so this is simple, 24.5, right? And area shaded region, your shaded region basically is a big sector minus the two segment. Again, I like to use area of segment, it's so fast and furious, right? This one minus these two segment. I put a dotted line here so that you can see that they are actually part of a sector of circle, right? So area of sector is half r squared theta, 6.712 squared. Whoa, whoa, whoa. Your theta is 3.8. Area of segment is half AB sine C, sorry, half r squared theta minus sine theta. Okay, I'll write over here half r squared theta minus sine theta. This is formula for area of segment. Your radius for this segment here is 7 squared. Your theta is 1 radian minus sine 1 radian. But I need to times 2. I need to times 2 because there are two segments. Right. Please use your calculator in radian mode. Okay. So I think you get 77.83. Yeah, 77.3. And the textbook answer is 77.80. Again, slight difference in answer. Okay, you can also use area of sector and area of triangle if you want. If you want, you can use area. Yeah, but I think it's not necessary lah. Yeah, it's not necessary. Some people they take the area segment, area triangle. I think I just use area yeah, the whole thing is easier. Okay, all right, next one. Question number 13. Diagram on the right shows sector circle with center O, radius 2 cm, inscribed in the sector PQR, presented P. PR is a tangent, find arc length. Okay, number 1, I will draw a line across. Draw a line across. I know this is 30, 60 bisect is 30, this is 2 cm. I need to find the length of OP first, because in order to find the length of arc, I need to find the length of PR. But one thing, please don't look for PR directly, because we can't find PR directly. You're going to find PO, let's call this T again. You're going to find POT. Now we know OT is 2 because it's the radius of the circle. I just have to find PO. Now if you redraw the triangle like this, you can see that this is POB, this is 2, this is 60. We know we can use sine, right? Sine 30, not 60, 30. Half of it already. This one is 30. So sine 30 is 2 over OP. OP, use your calculator in degree, please be careful, it's 30 degree, not 30 radian. Calculator in degree mode, your OP will be 2 divided sine 30 is 4 cm. So the length of POT is now 4 plus 2, which is 6 cm. If your length POT is 6 cm, this is part A. If your length POT is 6 cm, so this is 4 plus 2, 6 cm. Your length of arc QR will be r theta. R is 6, theta is 60. You can convert to radian. times pi over 180. Okay, but I want to say this again and again. Textbooks somehow they like to use theta everything in, they like to round off first to decimal point, 3 decimal, and then they count. So sometimes because of that your answer a bit different, right? Um, I actually got 6.284, but the textbook, because they round off first, they got 6.282. Okay. Remember, even if I do this, I will always use 3.142. If you type in directly, you get 6.284. But if you round this off, then you type in the calculator, then you get 6.282. That's why that's the problem, right? Actually, rounding off more is not good, right? It's a bit inaccurate. But the plus point is that you keep writing this off. You don't have to keep converting times pi over 100t over and over again, right? Okay. Next, find the area of shaded region. So shaded region consists of this big giant sector here. Oops. You minus this triangle times 2 and minus this sector. Okay, your big sector, right? We can use half r squared theta. We already know the radius. The radius is 6. Theta is 60. Again, the text will use 1.047 because they just round off and use this figure. All right, and you minus area triangle. Okay, this triangle, right? We can actually find the length of PB first. Okay, look at this triangle here. Your PB, since I know this is 4, right? I use Pythagoras. 4 squared, 2 squared, square root 16 minus 4 square root 12. Okay, I would find this first as square root 12. So I can use half times base times height. So I use half times base times height times 2 because I have 2 triangle. And we know this is 100, this is 60, this should be 120, yeah, because this is 90 and 90. If you use your calculator, 360 minus 60 minus 90 minus 90 is 120. And if this is 120, this is 240. Yeah, personally, I like to use directly, I would like to take half, radius 2 square, 240 times pi over 180, yeah. Alright, I will do this. Oh, you can't see the end here. Okay. Okay, maybe I write below here. Let me write below here. You minus half r square. R square is 2. Your theta is 240 times 500t. Okay. All right. Now textbook's answer is 3.54. Now if you were to use like what I do, I use this value here into here, right? Then your answer is slightly different. It will be 3.545. Right? So textbook answer is 3.54. I think because they round off the 1.047. Okay, that is number 13. Okay, let's move on to question number 14. Okay, now diagram shows the plan of a garden. AOB is the sector of a circle with center O, radius of 18. ACB is a semicircle. AB is a diameter. Sector AOB is the garden is covered with grass, while creepers are planted in the shaded region. So this is your grass and this is your creepers. Creeper sounds very creepy. All right, now then area covered by the grass is 2, 4, 3. So to find angle theta, we'll just use half. Your radius is 18 square theta. The result is 243. Okay, use your calculator. 243 times 2 divide by 18 square. I got 1.5 really. Alright, that's the first part. Second part, find the length of fence needed to enclose the creeper. So the length of fence consists of length of arc AB here and arc ACB. There are 2 arc here. So your arc AB, no problem, we can use S equals R theta. Arc ACB is a bit of a problem because we do not know the radius of your semicircle. This is your semicircle, right? So we need to find the radius. We need to half this. Okay, I'm going to rub off the grass thing, right? We're going to cut this in the middle, and this will be your theta 2. Or you can use the formula for chord, right? You can just use chord. Okay, chord is 2r sine theta 2. It's very, very fast and furious formula. Your radius is 18. Theta is 1.5 divided by 2. Can you write 0.75? Calculator in radian mode, please. you should get 24.54. Okay, but this is your diameter, not your radius. Your radius, you have to take this divide by 2, 12.27. Yeah, this is your radius, or you can call this t again. This is the length of AT, radius, half of it. Okay, I need this so that I can find the length of arc ACB. Now, my length of, let me move this up a bit. Okay, my length, you can't see the 8 here. You can't see what I wrote here. The radius is just 80. Let me just show you again. Okay, this is just 80, but you don't have to label. Okay, so I want to find the uh, length of the fence. So your basically is your perimeter, yeah, or you can just say length. Maybe I write length better. The length of the fence is, the first arc is 18 times theta, which is 1.5. The second arc, the radius is 12.27. Your theta is just pi, r theta, pi, because it's 180 here. Yeah, 180 radian is just pi. Please use 3.142 though. You will get 65.55 meter. Okay, next, how do you find area planted with the creeper? So again, you can use area segment if you want, or you can use area triangle one by one. So I personally like area segment. Like I would take this minus this. Okay, I should just use one moment. Area. Okay, let me draw this out. I would use this. Oh, wrong. This one. This semicircle minus this segment. I will actually prefer this. Yeah, minus this off to get the shaded region. Okay, so if we to use this method, half r squared theta, your radius is 12.27, square theta is pi, area segment is half r squared, theta minus sine theta. But please use your calculator in radian mode because this is in radian. Okay, your answer, if you use this method, your answer is 155.11. Okay, but the textbook answer is 155.07. Okay, now let me just show you another way. Another way of doing will be, I use area of triangle plus semicircle minus area sector. All right, your area triangle, I know a lot of people use half times base times height. That means you have to find the height. You have to go back to this triangle here. I know that, okay, since I don't have enough space, I'm just going to draw here. I know AB is 12.27. This part here. Too many lines, a bit confusing, so I'm going to rub off and redraw here. This is 12.27. Let's find the height, OT here if you like. Your OT is 18 square minus 12.27 square root, which gives us 13.17. Okay, so you might want to use area of triangle, which is half times base 13.17 times height 12.27, or we don't use 12.27, we just times this at 24.54, which I really know earlier, right? If you use 12.27, I have to times 2. Okay, so let me just times 24.54. Then you plus area of semicircle, which is half r squared, 12.27 square theta is pi. Then you minus your area sector. Actually, area sector we know is 243. Okay. Now, if you use this method, I still get 155.11. Yeah, I wonder if the difference in the answer the textbook could boil down to this uh, what do you call that, the rounding off part, maybe they round off earlier, or yeah, that's why, or when it comes to using a triangle, that's why answer is a bit different. But it's just a slight difference. It is bound to happen. Okay, now let's look at question 14. Hilal ties 14 of strings together by a string shown in the diagram. A radius of each tin is 5.5. Calculate the length of the string used by Hilal. Oh, this will be an excellent question for Form 2 maths. Why? Because we don't have to use S equals to R theta. We basically use area of we use a circumference of circle, right? So let me just draw for you. A bit hard to see. I draw 4 circles. 1, 2, 3, and 4. Man, my circle is not very round. Okay, so never mind. Sorry, forgive me for my ugly drawing. So this one you join together. We know that the radius of each tin is 5.5. Okay, so if this is 5.5, 5.5, can I say this length is 11? Correct. Now you do the same for here. Sorry, supposed to be touching. So ugly. This is 11, right? Do the same for here. What is this length? 11, right? Do the same thing for here. What is the length? 11. So the length of string that you need is actually here. Quarter of a circle, 2 quarter of a circle, 3 quarter of a circle, 4 quarter of a circle. So you put 4 quarter of a circle together, what do you get? You get 1 circle, circumference. And then how many 11 do you have? 1, 2, 3, 4, 11. Right. So we say the length of the string that you need is length of 1 circle, which is 2 pi r plus 4 times of 11. Oh, it's actually 11 pi plus 44. You can use your calculator in 3.142. Please use 3.142. You should get 78.562. Okay, but I don't know. The textbook gave 78.564. Yeah, I wonder what is the problem. Yeah, I still cannot find the reason. Yeah, I got 562. I don't mind text, we use 564. Alright, so this is the answer. Alright, I think I just have a couple more. The next one. Okay, 16. Now this one I wouldn't have space to write the answer right below. Okay, you have a rectangular piece of aluminium measuring 200, 110 bent to form a 2 semicircle. This is a semi-cylinder. Blah blah blah. The container is held horizontally. Water is poured into it. Then the two sides you cover with semicircle. Okay, so you're supposed to calculate. Okay, so I think you can see. I don't have to like show you this again. I move this. I'll just redraw the triangle for you. Okay, so the triangle should. I redraw the semicircle for you. This is the second one. 1180 OPQ. Okay, so first of all, they say what is the show that the radius of cylinder is about 35. Okay, if you go back to the question, you can see here the length of this semicircle is 110, right? So we know semicircle is pi r, or you can either say r pi or pi r. Maybe I just write pi r is 110. Okay, use your calculator. 3.142. 110 divided by 3.142, you should get 35. Okay, nearest integer. Okay, or just write show. Nearest integer. Okay, second one. You're supposed to find the area of sector POQ. Okay, area sector POQ. We know the radius is 35, so we can use half r squared theta. Again, I think to make my answer similar to textbook, I will just round off. Like the textbook, like I say, they tend to round this off times pi over 180 first before they do the rest. So this is 2.060. Okay, Then I use area as half r square 2.060. Yeah, if you do this way, your answer will be the same as textbook, right? Which may not be the most accurate, right? Because they round it off. So it's 1261.75. Okay. Next, this is B Roman 1. B Roman 2. What are we finding? We're finding area shaded segment. Okay, I like the formula for segment, which is half r squared theta minus sin theta. Okay, half r squared. Your r is 35. Theta is 2.060 minus sine 2.060. But please use calculator in radian mode. I got 721.09. Okay, I think the textbook again they like to split in the middle, right? If I were to split them in the middle, right? Okay, let's see. We split this in the middle to find the height, right? We can say, okay, let me redraw a triangle for you. I don't know whether, yeah, you should have enough space. This is 35, okay. This will be 59. I find the height. This is very long because you find both sides. So you can either use sine first or cos first. So calculator in degree mode. So let's say I use sine 59. I'll get, this is your base, this is your height. So it's b over 35. So 35 sine 59. Oh, I got 30. Okay, your base is 30. Okay, your height, I think we can just use 35 square minus 30 square square root. That's better. 35 square, 30 square root 325. Okay, and your area, if you were to use this method, is area of sector half r square theta minus half times base times height. Your base is 30. Maybe you can just times 2. If this is 30, double is 60. So I just use 60. Height square root 325. Let's see whether I can get the same answer as the textbook. Minus 30 square root 325. Okay, I got 720.92. 92. Not close. The other one 721, this is 720. The textbook question is, textbook answer is 720.945. Okay, not closer, it is closer, but not exactly. Okay, so again, it's up to you, whichever method. Okay, lastly, volume of water in a container. You're finding volume water in a container. Well, volume is cross section times height. You already know the water is here, this one. The length of your container is 200. So we just take the volume equals to area times length. Okay, here again, up to you which one you want to use. I got so many answers, all right? So if you want to follow the textbook answer is this: 720.945 you times with 200, right? So again, you don't have to use such accurate answer. Why you need like 6 significant figure? I don't get it, right? Why do you really need 6 significant figure? No, right? So the textbook answer is 144,189. But remember, this is in cm cube. Now 1 cm cube is 1 ml, right? So this will be 144,189 ml. But you want your answer in liter, so you convert to liter. This is 144.89 liter, right? I hope you can see it. Can't see the n. Is liter, right? Okay, you can't see that. This is 200. Okay, so but if you use my answer here, you get a slightly different answer, but I think that's okay. We use this answer here, or even this answer here, yeah, a slightly different answer, right? But I think both are okay, because it's a matter of significant figure. If you round off correct to 4 SF, is they're all about the same, right? Okay, next one, the question about cake. Right, is it a cake? Oh, sorry, it's not a cake. A diagram shows a uniform prism where its cross section of a sector is a sector of a circle with radius of 3 cm. AOB, CED, they're identical. Cross section of prism with points A, B, C, D lying on the curved surface of the prism. The height of prism is 4, CED is 40. Find arc length AB. Okay, so to find arc length AB, wow, this one's a bit long. I think the first part we use S equals R theta. Okay, again, the textbook would tend to change the 40 to radian and round off to decimal, which gives us 0.698. Again, I personally would like to use 4SF. So I would use 0.6982, not 0.698. But the textbook answer, they're all 698, right? They base on theta equals 0.698, because what is the point of wanting the final answer correct to 6SF then when your first part is only 3SF, right? The accuracy is not there in the first place, in the first part. I would prefer to use this actually for accurate answer. Okay, next, let's look at S equals R theta. Your radius R is 3, theta is 0.698. Okay, if you just want to follow the textbook, right, to get the same answer, then we'll just do this. Your answer from the textbook is 2.094. Okay, if you use this 692, you will get 2.095. Yeah, just so you know. Okay, next, I want to find the area of sector. Area of sector, very simple, half r squared theta. Your radius is 3 square root theta 0.698. This is if you're using textbook. You should get 3.141. And again, if you use the other answer, wow, this is a bit annoying, right? You get 3.142. Okay, so I will show you two answers. Okay, I would actually prefer to write the other way around. I prefer to write my answer than textbook answer, but yeah, since I've written, never mind. Okay, next, volume. Volume of prism is just cross section times length. Okay, so if you use the textbook 3.141, your length is 4, you should get 12.564 square cube. This is cube. Or if you use the other one, my answer is 12.568. Yeah, depending whether you're using 3.141 or 3.142 from part B. Okay, D, the total surface area. Okay, total surface area here is very interesting. You need to find the length of this arc first. Alright, which is 2.094 if you're using textbook. Then you plus times with this length, because when you open up, the layout is actually like this. It looks like how do I show you? One on top, one below, one here, right? Wait, I need to show the other side as well. It doesn't look very nice. Okay, I think I show the other direction. Okay, that means okay, one more time. This is your base, right? This is your rectangle. This is another rectangle. There's a top circle here. Then there's this side. This is your curved surface area. Wow, very ugly. So there are 5 parts to it, right? The curved surface area, actually, this is the same as the length of this arc, and this is the height of your prism. So there are 5 parts to it. Okay, we actually already have all the things that we need. Okay, let's start off with the 2 rectangular side. 3 times 4 is 4 times 3, right? I have 2 of them. Then the area sector also already have it here, 3.142, 141. I have 2 of them. All right. And then the back part, like I said, is actually a rectangle with the length of 2.094 times the height of 4. So it's 2.094 times 4. and your total surface area will be 38.658. Okay, now this is of course if you use textbook 3.141 to 2.094. Yeah, if not you will get 38.664. There is always a problem with accuracy. You see, you want to give a final answer correct to 5 SF, but then this is already only 3 SF, right? So yeah. Okay, I guess this is next one is the last one. Yeah. Well, it has been such a long recording. All right. Now, Mathematics Society of SMK Taman Pago Indah organized a logo design for competition. This is quite similar to the recent SPM question. The logo you can see is designed by Wong made up of identical sectors of circle with radii of 5 cm. Okay, if you look at this arc here, right? And if you join these together, okay, maybe let's not focus on the arc. Let's focus on the center line. I want to draw this center line so that you can see this is 1, 2, 3, 4, 5, 6. Can you see? It's a regular hexagon, and the angle subtended at each side here, each triangle here is 60. And because it's a radius, they are all 60 degree. Can you see that? They are all 60 degree. So first thing is you need to find out the angle. Okay, we are supposed to find perimeter, so I'll just draw one of them for you. So you can see this is 5, 5, and this is also 5. This is 60 degree. So your theta is 60, but you convert to radian. Again, textbook like to convert to radian, use 3 SF, 3 decimal, right? 1.047. So then you count how many color region you're finding perimeter color region, right? So okay, let's just rub this off. Let's count how many you have. I'm gonna use a black pen. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 of them, right? So basically you just find length of arc of 1 and then you times 12. So your perimeter is S equals R theta 1.047, then you times 12, you should get 62.84. Okay. Okay, I think textbook is A2. Textbook is A2, not A4, because if you use 1.047, you will get A2. Yeah, if you use this directly, I think you get A4, but doesn't matter. I'll just use A2. Okay, next, I'm finding area of color region. Okay, again, I like to use area of segment. Personally, I like segment because it's fast and furious, right? So, and I really explain to you all, right? You can just use half r squared. Your radius is 5, theta is 1.047 minus sine 1.047 in radian. This is in radian times 12 because I have 12 of them, right? You should get 27.146. Okay, or you can write 15, right? Okay, the thing is the textbook answer is 27.12. Okay, let's see. I guess again the textbook will split this into 2. So if this is 5, this is 2.5. We can find the height of the triangle here. The height is 5 square minus 2.5 square with the square root over, you should get 18.75. So your area will be half r square theta, area 1 sector, minus area 1 triangle, half times base times height. Your base is 5, your height is square root 18.75. So whatever that we have here, we times 12. Okay, and with that, I think you will be able to get 27.12. Again, it's a bit of a it's up to you, whether you want to use the long way or short way, but actually should be accepted. But if you want to get this answer to be closer to this answer, then you shouldn't use 1.047. You should use this directly. In fact, I would use sine 60. If you use sine 60, okay, let's try. If I use sine 60 here, sorry, use your calculator in degree. I think it would be closer to the other answer. Okay, let's use your calculator in degree mode. Right, type in your calculator. Half r square 1.047 minus sine 60 you times 12. Yeah. Oh, still about the same. If I use 60 times 3.142 over 180 minus sine 60 times 12, yeah, I will get 27 point. So it's a bit far as well. All right, it's okay. I'll get this answer actually, the same answer. All right, that's all for this video presentation. Oh, if you enjoy my video, like, subscribe, and also if you want more exercises practice, we have past year question, notes and tutorial, topical practice, drill practice, yeah, and so on. You can find us from Shopee, Lazada, or contact us. Yep. Thank you for watching. See you in the next video.